Today let us look at nature of roots of a standard quadratic equation. We know that for a quadratic equation ax square plus bx plus c is equal to 0, the roots of the equation are given by minus b plus minus square root of b square minus 4ac upon 2a. Now this formula gives us two roots of the given equation, or two values of x that satisfy the given quadratic equation. Now notice the term under the square root, b square minus 4ac. Now this term is known as the discriminant. Now there are three possibilities. One, that the discriminant is positive. Second, where it is equal to 0. And the third, where it is negative or less than 0. Let us look at the first one. When b square minus 4ac is greater than 0, then we have real roots. When b square minus 4ac is equal to 0, we see that x reduces to minus b by 2a because the square root term vanishes. So we have equal real roots. However, when b square minus 4ac is less than 0, then the square root does not give a real number because we are trying to find square root of a negative number. So in this case, we do not have any real roots. Let us look at a few questions. Find the nature of the roots of the following quadratic equations. Let us look at the first one. Now since we want to find out nature of roots, let us look at the discriminant, b square minus 4ac. Let us identify our a, b and c here and substitute the values. We find that the discriminant is minus 8, which is less than 0. Now recall our three possibilities and we see that this equation does not have any real roots, therefore no real roots. Let us look at the second case. Once again, we try to find out the discriminant here. We see that it is equal to 0. From our three possibilities, we see that it has equal real roots. Let us look at the second question. Find the values of k for the quadratic equation to have two equal roots. Now recall the condition for two equal roots. The discriminant, or b square minus 4ac, should be equal to 0. Let us find out our quadratic equation first by opening the bracket and identify a, b and c here. Let us substitute the values in b square minus 4ac and put it equal to 0. Solving for k, we see that either k is equal to 0 or k is equal to 6. Now let us check which of these values would give us equal real roots. If we put k is equal to 0, we get 6 is equal to 0, which is incorrect. That's not possible. Hence k is equal to 0 is not a solution. Let us check for k is equal to 6. Yes, this gives us two equal roots, 1 and 1. Hence k is equal to 6 is a solution, which means that for k is equal to 6, this quadratic equation has two equal roots. Let us look at another question. Is it possible to design a rectangular park of perimeter 80 meters and area 400 meters square? If so, find its length and breadth. So we have a rectangular park and the perimeter, that is 2 times length plus breadth, is given as 80. Let us write B in terms of L. Now we are also given that the area is equal to 400 meters square. So let us substitute the value of B in terms of L and we get a quadratic equation in L. Now we have to see whether such a rectangle is possible. So for this rectangle to exist, the quadratic equation should have real roots. So b square minus 4ac should be greater than or equal to 0. Let us identify a, b and c and substitute the values. We see that the discriminant is equal to 0, which means that this quadratic equation has real equal roots. So let us solve for L. Let us apply the quadratic formula here. Substituting the values, we get L is equal to 20 meters. Solving for B, we see that the breadth is also 20 meters. So the discriminant tells us whether such a rectangular park is possible, and the quadratic formula gives us the dimensions of this rectangular park.